All right, let's look at another situation where instead of being given boundaries, we're just given two curves. So here's what we need to know. Looking at my two curves, y equals 2 minus x squared. I know all about that one. It's a parabola that starts at 2, opens downward. I know about y equals negative x. And so taking a look, here's what I need to know in order to be able to solve this problem. I need to know where those two x values are. Well, this is a system of equations. So I'm going to set them equal. I'll just use the equal values method. And I get x squared minus x minus 2 is equal to 0. This is actually a pretty easy one because it factors nicely, and you could use any strategy you wanted. You could use quadratic formula. I wouldn't recommend using your graphing calculator. In this case, you would get x equals 2 and x equals negative 1 as your boundaries, which would in fact be accurate. But, what do you do if it's not quite so accurate? And so I'd recommend using a more accurate strategy than just looking at your graphing calculator and trying to find intersections. So now here's what we got. I want the area between these curves, which means I'm looking at the integral from -1 to +2 of top curve 2 minus x squared minus bottom curve. And I'm going to write this out rather than do the math in my head and make mistakes. So now I've got the integral from -1 to +2 of 2 plus x minus x squared dx. Of course, the antiderivative, I'm going to jump to the next page. The antiderivative of 2 plus x minus x squared dx from -1 to +2 is 2x plus 1/2 x squared minus 1/3 x cubed. And we are evaluating this from -1 to 2. And with a little bit of simple math, what we discover is that this is equal to 9/2 units squared. And of course, my phone immediately goes off. All right, so why don't you go ahead and do exercise 5, and I will be back with, you know what? Let's do one more quick example. This is example 3. This is one that requires the use of a calculator because what we've got is y equals 2 cosine x and y equals x squared minus 1. Looking at our graph, we see that this is a parabola that looks like that. It's a cosine function that looks like that. We don't really have any way to solve 2 cosine x equals x squared minus 1. So what are we going to do instead? We're going to actually go into the calculator. And what we can do is we can use the int function or intersection function in our calc menu if you have a TI-84. And the way to do this is to calculate an intersection and then type in STOA and then calculate the next intersection and type in STOB. And you can find that on your calculator. You'll see the store button down at the bottom. Because the advantage now is that when we type in the integral, we can actually recall A and recall B, or we can just put in A and B into our integral of 2 cosine x minus x squared minus 1 dx. And because we've stored those, we don't have to waste our time jotting down these 9-digit numbers, 2 of them, and then retyping them all back in. And this will give us an answer of about 4.995 if we round to 3 decimal places, as is usual in AP calculus. All right, why don't you go ahead and do exercise 7, and we'll be back with a new video and a couple more ideas. All right, thanks for watching.